So let's just work through this integral real quick. Remember, rho is 1,000 kilograms per cubic meter, g is 9.8 meters per second squared. But the nice thing is you actually don't have to know that until you get to the end of the integral. All you need to do is remember that rho and g are constants. So you could rewrite this with all the constants out front, rho times g times 3, integral y equals 1 to 3.5 of y dy. Again, that's rho times g times 3. What's the integral of y? It's just 1/2 y squared from 1 to 3.5. So again, that's rho times g times 3. I can move the 1/2 out and just plug in the 3.5 for y, so we get 3.5 squared minus 1 squared. You can look it up real quick. 3.5 squared is 12.25. So you get rho times g times 3 times 1/2, 12.25 minus 1, which is, of course, 11.25. So now is maybe when you'd throw in all the values for the constants. So 1,000 kilograms per cubic meter times 9.8 meters per second squared times 3 meters times 1/2 times 11.25. What are the units of this 11.25? Well, the 1 and the 3.5 are meters, and we were squaring them, so that's meters squared. So I've got meters squared and meters there, meters cubed here, so that all cancels. So overall, I get 16,5375 kilogram meters per second squared, which is newtons, so that all works out. Is that a lot of force? Remember, 1 Newton is roughly 1/10 of a kilogram. Now here I really mean kilograms. Here I mean how much a kilogram weighs in terms of force. So what we have is basically 165, 375 newtons divided by basically 9.8, and you get 16,537 kilograms of kind of force on Earth. So the total force pressing on that window is like laying it sideways and putting 16 tons spread out all over it. So that's a lot of force, right? That the glass better be, I don't know, 4, 6, 12 inches thick, you would hope, and the mounts around the edge of that window had better be pretty darn strong.